Everyone, welcome to GeekNerd. Today we are going to solve the 12th question of array, that is maximum length Bitonic subarray. Previously we have solved 11 questions and the solution of the question is there. You can click over here and then click the link and you will redirect to the video solution of it. Okay. Now we are solving the 12th question, that is maximum length Bitonic subarray. So you have to click here and they click the link and you will redirect to the question page. It's a Geeks for Geeks question. So let's read the question. Given an array ARR containing positive integer, there is a array ARR which has positive integer. A subarray array I to j is Bitonic if there is k where I less than equal to k less than equal to j, such that array of I less than equal to array I plus 1 less than equal to array k greater than equal to k plus 1 and greater than equal to j minus 1 and greater than equal to j. It's like there will be a subarray where uh, from I to j for the starting it will increase or it will remain same, and then it will decrease or remain same. Okay. So that kind of subarray should be there, and that subarray should be Bitonic subarray. Okay. Return the maximum length of the Bitonic array subarray. So we have to find all the possible subarray and return the maximum length of a Bitonic subarray. For example, here 12, 4, 78, 90, 45, 23. So here the output is 5 because here like from 12 to 4 it is decreasing. So let's take this example and check uh, how many Bitonic subarray are there. Okay, so I will make it little bigger. Okay, now it's visible, I think. So okay, so let's take this example, and as you can see, I could be lesser than equal to, like here we can take the subarray also, like 12. It is also a Bitonic subarray because here we can have I is less than equal to k less than equal to j. That means I can be j also. Like we can have a single element array, and that is also a Bitonic subarray. Okay. Let's have this 12 comma 4. Let's think that 12 comma 4 is a Bitonic array. What do you think? Yes, it is, because I can be equal to k also. So from k we can start, and it is decreasing. So 12 is less than 4. It is also a Bitonic array. So for now it's the size of maximum size of the Bitonic array is 2. We have encountered the maximum as 2. Okay. Can we have 12 comma 4 comma 78? Is this subarray Bitonic array? Hmm. First it is decreasing, then it is increasing. It's not possible, right? First we need a array. Either it is increasing or it is same. Then either it is decreasing or same. After that we can't increase, right? It should be like in mountain or it is a plain land. Okay. So here it is like going down and then up. So it is not possible. So it is not a Bitonic array. Okay. So okay. After that we can't take any other element, right? So let's start from 4. So is 4 a Bitonic array? Yes, it is. Okay. Let's take 4 comma 78. Is it a Bitonic array? Yes, it is, because it's increasing and then stop. we can have that Bitonic array because k can be equal to j also. So basically we are only focusing on increasing, not like the plain or decreasing one. Okay, so it is a Bitonic array. Let's take 4 comma 78 comma 90. It is increasing, so it's a Bitonic array. Now we have three element in subarray, which is Bitonic. So here, from here we have encountered the maximum as 3. Okay, let's find another one for 78, 90 and 45. First it is increasing and now it's decreasing. So we can, as it is increasing and then decreasing and not again increasing, so we can consider it as a Bitonic array. So now we have maximum as 4. Okay, now comma 78 comma 90 comma 45 comma 23. Is it a Bitonic array? First it is increasing 78. So 78 to 90 it is increasing. Okay, great. Now 90 to 45 it's decreasing. Okay. And 45 to 23 it is decreasing. So it's like a mountain. So we can have it as a Bitonic array. So the length of it is 5. The maximum is 5. So after that we can't find a maximum. So we consider this as a Bitonic, the largest Bitonic array. So this is the largest Bitonic array, and so the length of it is 5. So we are returning 5. Like that array 10, 20, 30, 40. So as it is increasing only, so we can consider it as a Bitonic array. So here the output is 4. So we are, from this question we are expecting time complexity of big O of n and auxiliary space is a big O of 1. Okay. Mhm. Let's see. Okay. So the first approach for the brute force approach. What will be the brute force approach? If we as we are doing here also, we are checking every subarray and then checking that for each subarray we are checking, is it a Bitonic subarray? If it is a Bitonic subarray, then we are saving the length of it, and if it is maximum one, then we are returning the length of it. Okay, so we can do that in the code also. So we will iterate, will search over every subarray. So how will we go for every subarray? Then we can have a nested loop. So I'll iterate from the 0 to length minus 1. So int n is equal to dot size. So I'm saving size of the array in n, and now I'm iterating over it, and then we are going to have another one. Why we are having the nested loop? Because I'm considering I as the starting point and j as a ending point. So I'm going to have every sub array. So now now we are assuming like some function is returning. Uh, we have a function that is returning. We are giving a subarray of the given array, and we are getting a boolean value. If it is a Bitonic array, then we are getting output as a true, otherwise a false. So if we get true, then we are having the length of it, and if it is maximum then encountered one, then we are going to return it. So as the size of the array is starting from 1, So if we have single element in the array also, the maximum Bitonic subarray length will be 1 only. So we are assuming the initial answer is 1. Okay. And if we find this as a Bitonic array, then we are counting as like we're comparing with the answer, and if we find an answer more than the previous answer, then we are going to update the answer. Okay, so the length will be j minus I plus 1. Okay, okay, so we are going to have a like function for this. So is Bitonic sub array. Okay, and we are going to pass given array starting point and ending point. Okay, public static boolean is Bitonic sub array list of integer arr int start and int end. Okay, great. So I am going when it will be a uh, Bitonic array, right? So first, either it should be increased or stay same as it is, huh? Or it will be decreasing and or stay as it is. In the end, we like this will be the sub array. After that, nothing matters. Okay. But if after decreasing it get increased, then that is not a Bitonic array. Okay, so I will have a iterator int I is equal to 0. Okay, I will iterate till length of the array. So let have n is equal to array dot size. Okay, and we are going to iterate till n the end of the element. No, I think we should not um, iterate till end. We are checking the subarray, so it's like E. Okay, it's the end of it, right? So and okay, okay. If we find okay, we have for the first thing like we have to continue till it is increasing or equal. When we get a decreasing one, like when arr dot get I is greater than arr dot get I plus 1, then we have to break, otherwise increase. Okay, while now if after breaking it from it like we completed the increasing or equal part. Okay, after that it should decrease or stay remain same. Okay, so when we will be break out of it, we'll break out of it when we find a element that is smaller than the next one, then it will be increasing. Okay, so I less than and okay, and when we are beginning, I should not start from 0, it start from start, because we are checking the sub array. Okay, so if arr dot get I is less than arr dot get I plus 1, then we have to break, otherwise I plus plus. Okay, then at the end, if we reach the last element, that means if I is equal to n, that means we covered the array and the condition that we have written is satisfied. Okay, but if it is not, then that means it is not satisfied. So we can return I is equal to and it's done. Let's compile. Okay, what's wrong? Okay, we are not returning the answer, so we have to return the answer, right? Okay. Okay, it's passing the compile the test cases. Let's submit it. Mhm. It's taking time. Mhm. It is taking time. Mhm. Okay, there is a runtime error. What it is? It is saying time limit exceeded. Okay, why is that? Because we have nested loop. Okay, if you're seeing it, it's look like big O of n square, but we are calling a function inside the nested loop, which is big O of n. So here we have big O of n, and here outer side big O of n square, and as it is nested only, so the time complexity of it is big O of n cube, which is very high. So we have to optimize the solution. So how can we optimize the solution? So in this question you can see that we have to make sure that, like, if we are at a particular index, then we have to check that, like, is the left element is increasing, and the right element is decreasing, then we can get a particular Bitonic subarray, right? So if we know that, like, if the left element is increasing to how much, and the right element is decreasing to how much, then we can easily get the particular length of the Bitonic array easily. Huh? So to optimize the solution, we have to have a optimum solution. So let's explain. I will explain you with an example here. So here, okay, let's have like this only. So this is the array. Hmm? So we are going to have two more array. Okay, one will count the increase, like, non-decreasing array, like it will count up to how much it is in the non-decreasing. Then we have another array, and which will iterate from the right to left and check whether up to how much it is increasing, okay, or not decreasing. So let's have it as a increase, like non decreasing, and here as a non increasing. Okay, so for this non decreasing, we'll iterate from the left to right. Okay, so here uh, at first I will have a 1, huh? Because if we consider only 12, then there is nothing in the left. So at first, like, 12 is considered as only the Bitonic array, so we are going to have 1. Okay, now consider 12 and 4. I don't like, it's in decreasing order, so we have to calculate non-decreasing. So if we consider 12 and 4 only, then 4, if I want the increasing or non-decrease, maximum non-decreasing, then that will be only 1, because the 4 will be only there. Okay, now we'll check 4 is greater than equal to 78 or not. It is 70, it is. So then we are going to have 2. Okay, now 78 is greater than like less than equal to 90. Uh, is is increasing or not? Yes, it is increasing. So we are going to have 3 plus 1. Okay. Now from 90 to 45, is increasing? I don't think so, because 45 is lesser than 90, so we'll again reduce to 1. Now from 45 to 23, is increasing or equal? No, it is not. So you have only 1. Okay. Now think from the uh, okay, from right to left. Okay. So at first only 23 is here, so we are going to have 1 only. Okay. Now from 45 to 23, is in the non-decreasing order? 45 to 23, like, is 45 is greater than equal to 23? Yes, it is. So we are increasing 1. Okay. Is 90 is greater than equal to 45? Yes, it is. So we are going to have 3. Okay. And from 78, is 78 is greater than equal to 90? No, it is not. So we are going to have 1. Is 4 is greater than equal to 78? No, it is not. So we are going to have 1. Is 12 is greater than equal to 4? Yes, it is. So we are going to have 2 here. Okay. So after getting the 2 array, the will for a particular index we can find how many element to the right are there which are in the decreasing order, and or we can say non-increasing order, and to a particular index of if you move toward left to it, then how many elements are there which are in a non-decreasing order. Okay, so after finding these two, we'll simply iterate over every array and find like 1 plus 2 minus 1, because we have to find the left and right, and like left like how many elements are there including that particular index to the left in a non-decreasing order, and to the right in a non-increasing order. And as we are having two subarrays, we are counting the current index twice, so we have to reduce it by 1. So if we iterate over the uh, all the uh, index, then at the first index, 0th index, we have 2 plus 1 minus 1, that is equal to 2. Okay. Then for first index we have only 1, so 1 plus 1 minus 1, that is equal to 1. Okay. For the second index, 2 plus 1 minus 1, that is equal to 2. Okay. For third index, 3 plus 3 minus 1, that is equal to 5. Okay. And for fourth index, 1 plus 2 minus 1, that is equal to 2. Okay. For fifth index, 1 plus 1 minus 1, that is equal to 1. Out of everything, what is the maximum? The maximum is 5, so answer is equal to 5. Okay. If we consider the 5, then we are getting 3 plus 3 minus 1. if you consider this element now, so it's in the third index. The third index is 90. Okay. If we go toward three element from the 90, then you can see it's in the increasing order, right? Or we can say non-decreasing order. Huh? But 12 is if we include 12, then it is non-decreasing order. So we are getting a maximum length where from which the element, the list is in non-decreasing order. So here we are getting the 3. So these 3 we can consider as a non-decreasing order, and here non-increasing order also we are getting 3. So if we consider from here to 3 element, then we can see it's in the non-increasing order. Okay. So here from here to here it is non-decreasing order, and from here to here it is non-increasing order. And if you consider this whole, it is a Bitonic array. So from here to here it is increasing, and here to here it is decreasing. So for the both the subarray we are considering 90 twice. So we are reducing by it by 1 and calculating the length of the Bitonic array. I hope you understood this thing. So let's convert this logic to code. Okay. So there are two array we are initializing is. First we have length. Okay. Now we will have no array of it. Non-decreasing is equal to new int and let's have, okay, sorry, let's duplicate it. No, okay, I'll try it again. Hmm. Okay, for first I will iterate. Okay, first for the non-decreasing order, so we are initializing the zeroth index as 1. Okay, and iterate from 1 to end plus, and if we are finding non-dec I is greater than, as we are, as it is in the decreasing order, so or we can select I minus 1 is lesser than equal to, like here, as like this, it like this. Okay, uh so non decreasing I. Hmm? So then what we'll do, non dec I is equal to non dec I minus 1 plus 1. Okay, else non dec I will be 1. Okay, like that, non in n minus 1 is equal to 1. For this, we will iterate from right to left. So for int I is equal to n minus 2, I greater than equal to 0, I minus minus. If non-dec I is like this, it will like this. Okay, so here equal greater than equal to non-dec I plus 1, then non-dec I will be non-dec I, sorry, it's not non-dec, non-inc. Okay, sorry, non-inc, non-inc, non-inc plus 1 plus 1. Okay. Hmm? Else non-inc I will be 1. Okay. Now we have the both the array. Now we will iterate over both of them and then calculate this and return the answer. So for that I am assuming answer is 1, and then I have to iterate over I is equal to 0 to I less than n I plus plus, and answer should be math.max of answer, comma, we have to compare and return the maximum in answer. Okay, so non-dec I plus non-dec inc I, as we are counting the same element twice, ith element twice, so we'll reduce by 1. Okay, and in the end we are returning answer. Let's see. Okay, something is wrong. Hmm, it should not be 1, it should, the answer should be 5. Okay, let's check. Hmm, hmm, okay, n minus 1 1 greater than equal to, okay, okay, it's okay, then hmm, everything looks good. I don't know why it's happening like this. Okay. Mhm. Okay, let's dry run it. Then we'll get to know what's wrong. Okay. Okay, we have created the both of the array. For non-dec 0, we are having 1 at the first. Okay. Then we are iterating hmm, from 1 to n. So non-dec of 1 should be less than equal to non-dec of, okay, non-dec of I minus 1. Non-dec of 0 should be less than equal to non-dec of 1. So it's correct. So I minus, so sorry, I non-dec of 0 should be less than equal to non-dec of I. So it's 1. It's correct. Huh? Same for 78. Uh, it is in the less than this. So it's 2. 90. It's less than this. So it's 3. Then we are going to have 1 as it is not following. Correct. Then n minus 1. It's 1. Okay. From 2, we are going till 0. So if non-inc I is greater than equal to, okay, and that one, that's correct. It's 2. Then it's going 3. Then it's going lesser, so it's 1. Then 1. Then 2. Okay. Answer in the answer is equal to 1. Okay. We are iterating over every element. Okay. Mm, non-inc, non-dic, non-inc, I. Okay. Everything looks good, but let's print this. Non-dec I plus non-dec non-in. Let's see what is this printing. Hmm. Everything is coming one. It should not be like that. That means everything is okay. The problem here is okay, I got it. I got it. It's a very silly error. Why are we checking the non-dec? We should check array, right? Okay, it's very silly error. And even I am dry running it, I'm doing wrong. So, okay, it's okay. I think now, okay, as it is a list, so we should use dot get instead. Okay, my bad. Sorry for this. Um, okay, now if I submit it, okay, I think it will be solved. Yes, it is solved. And this approach is taking big O of n as the time complexity. So the time complexity for this program is big O of n because we have one loop and two loop. We don't have any nested loop. Okay. So that's it for now. I hope you have understood everything that I have explained to you. If you like the video, then please click the like button. It means a lot. If you have feedback or any suggestion, then comment down. If you have question also, you can comment down. I'm watching every comment in my channel, and if I can answer it, then I will sure do it. Okay, I will try to answer every comment, and please subscribe the channel. It will motivate me to make this kind of video more. Okay, so thank you. Have a nice day and keep solving lit code questions or GFG questions. Okay, so bye.